let's kind of talk through how many questions are on the final and that kind of thing. And there's more than 10. Okay, so there are 19 questions in total. They are multiple choice and multi-select. Okay, so that's like where you have like the drop down or you check a checkbox. For multiple choice, I don't know why I put a slash through here, when multi-select. Okay, now let's talk about the different types of questions. This is what the county gives us, and they tell us, hey, you get 6 questions on these AKS. Now notice there are 1, 2, 3, 4, 5 AKS, but there are 6 questions. So one of these repeats. Does that make sense? Most of these are solving. So like AKS 20 is like solving radicals. Okay, that's on your final exam review guide. Cool. 8 is geometric series. So something that looks like that, right? Okay, y'all give me blank stares. Okay, and we can kind of go through each one of these. This category deals with key features. This is identifying domain, range. It can be in context. It can be just regular function. Okay, but there are 10 questions. So that's where majority of your stuff is coming from. Okay, the last section is on stat. There's 3 questions on it. This is going to ask you about z-score, normal distribution, probably the empirical rule, things like that. Theoretical, can't spell today. You get the point. Okay, 19 questions in total. Okay, you have 75 minutes to complete it. Now, yes, I know we have 2 hours in this class, blah, 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 but by the time you sit down, you will have 75 minutes to complete it. Okay, you will have Desmos. There will be a formula sheet. The formula sheet, the same thing that was in that Unit 7 packet on page 19 and 20. That's your formula sheet for the final exam. Okay. Are there any questions about logistics of this test? Okay, cool. It's on the computer. It's like last semester. Now, to preface this, I have not seen the final exam. Nobody has seen the final, so we don't know what it would look like. The county gives us those CFAs though, and normally those are kind of similar to how the final exam has been structured. So keep that in mind. That's like the intensity level of the final exam. So I gave you a review guide looking at those AKS, but I don't know exactly how those questions are going to be asked. Does that make sense? I don't want you to be like, that was nothing like the review guide. Yes, because I haven't seen the final exam. Does that make sense? I'm not trying to like fail you on purpose. Okay. So question number 9 was the first one that somebody wanted to go over. Sketch the graph. Okay, so the first thing that you're probably going to be asked on here is to identify the graph. We're going to pull up Desmos because you're not going to be asked to do it by hand. And we're going to type in this. So we have square root of x minus 1. Okay. All right. So you can see from this, let's say we compare this to the parent function. Okay, so blue is parent function. That's the OG function. Okay, from the blue to the red, what happened? They move up. Did it move up, down, left, or right? Right. Okay, so it. Well, we want to go from the blue to the red.
So that's the first one?
Yeah. That's like the original. So from blue to red, we went to the right one. Does that make sense? There might be a question on your exam about transformations. That's in that 10 question category. Okay, so let's say, for instance, we had to do the transformation of this. The transformation would be that it moved right 1. That's it. That's all it would be. On your paper, what I want you to sketch is the point 1, 0. And then we're going to plot a couple other points. Okay, so 1, 0 is the first one you're going to plot. 2, 1 is the next one. And you can kind of go from there. You need at least 3 points in order to sketch a graph. So take a moment, draw that on. Okay, so majority of you should have typed in this. Now, one thing that I need you to make sure that you're paying attention to is where that square root actually stops. A lot of people put that +2 underneath the square root and it messes up their graph. You have to pay attention to how you're typing it in. Okay, so now if I'm going to graph this, I'm going to use my table and I'm going to plot about 3 points. Okay. So you can plot 0, 2, 1, 4, and 4, 6, and then connect those dots. Now between the parent function, so from blue to black, let's talk about the transformations. Okay, what happened between here and here? The blue to the black. Huh? Took away the 2. So from blue, so down here, to black, where did it move?
Oh,
Start from blue, so black. So where did that move? Up 2. And we can see that from our equation, right? Now, this 2 that's chilling out front, we see that the function gets like pulled up. We're going to call that a stretch of 2. Okay. Again, you're going to be asked some type of transformation on this. You need to be able to do this. While we're here, let's just talk about a couple other key features. Let's talk about domain. For the black one, what's our domain? What's our farthest left x value? What's the farthest left x value? It doesn't go past 0. So 0 is our farthest left x value. And then how far to the right do our x values go? So if I zoomed out, how far to the right does it go? Infinity, right? Okay, so we're going to say from 0 to infinity is our domain. What about our range? What's our lowest y value? What's our lowest y value? Lowest y value. What is our lowest y value? 2. What's our highest y value? No. Our highest y value. So if we zoomed out, does it keep increasing? It's infinity. Okay, so I want you to sketch this graph. I want you to identify the domain, the range. And this one, we're actually going to have a horizontal asymptote. So we're going to talk about that in just a second. So what kind of function is this one? Is it linear? Is it quadratic? Is it a log? Is it exponential? Is it? It is an exponential. How do we know that it's an exponential? Okay, it's an exponential because the x is in the exponent. Okay. So for all exponential functions, what's going to be the domain? What's your like go-to domain? Negative infinity to positive infinity. Let's think about that really quick. How far to the left does this guy go? If I zoomed out, it keeps going, right? Okay. How far to the right does this guy go? It keeps going, right? I mean, it's slow, but it keeps moving to the right. Okay. For our range, how far down does it go? What's the lowest y value? 0. And then how high does it go? Infinity, right? Okay, so again, domain is left to right, range is bottom to top. What's our horizontal asymptote? Where does it start kind of like tapering off but never touching? So what horizontal line? 0. So we're going to say y equals 0. Another way you could have seen that is that there's nothing added over here in the equation. So this is our horizontal asymptote, which happens to be 0. Are there any transformations that are happening to this guy? Well, if we compare 1/2 times 4 raised to the x of 4 to the x, what's the difference between these two? That 1/2. Well, 1/2 is going to shrink our graph. It's going to compress it a little bit more. So this is knowing your exponent rules, okay? Yes, knowing them is a good thing, but also you need to know how to use them. Okay, so on this first one, we have 49r raised to the second power, all raised to the negative 1.5. So if we see a negative in that exponent, we automatically need to think, flip it. Okay, so we got this parentheses around all of it. So we're going to flip all of this. So we're going to put it down at the bottom. Now we have an exponent raised to an exponent. So that means that we're going to multiply these two together. We're also going to take 49 and raise it to the 1.5 power as well, because there's actually an exponent of 1 right here. So if we do 1 times 1.5, we're going to get 1 over 49 raised to the 1.5. And then we're going to take 2 and multiply it times 1.5. So if we take 2 and multiply it times 1.5, what are we going to get? Not 2.5. So 2 times 1.5. Well, we've already flipped it, so we got rid of that negative, right? So that's going to give us 3. Good. Okay, so if I take 49 and I raise it to the 1.5 power, let's see if that simplifies at all. That gives me 343. So I could rewrite this as 1 over 343 r to the 3rd. You're good. Since this problem will be multiple choice, let me show you a cheat code way to do this. Okay, if I take the original function and I put x instead of r, watch what happens. So if I do 49 times x squared raised to the, that parentheses is real fancy, raised to the negative 1.5, and then I take the answer choice that I got, so the final result. I'll graph the same. You should have a line that crosses over each other, like they lay on top of each other. You may not have it exactly the same because we're having to simplify it, but you should have lines that overlap. Okay, so here it is. If I take this off and then I put it back on, you can see that that green line overlaps with this guy. Okay, now not the best way to do this, but you could do it that way. The one in the top, because we had to flip everything because that negative exponent right here. So it flips it down to the bottom. Can you try number 19? We're going to take everything that's on the inside and raise it to the 3/2. Okay, so I'm going to take each of these and raise it to that 3/2 power, right? So I'm going to take 81 and raise it to that 3/2 power. I'm going to take into the 6 and raise it to the 3/2 power. So I'm going to do 6 times 3/2. What's 6 times 3/2? Well, if we don't know, we can go into Desmos and we can say 6 times 3/2. And that gives me 9. Okay, so that's going to give me 9. So into the 9th power. Now let's see if 81 raised to the 3/2 will simplify. So we go into Desmos, we type 81 raised to the 3/2, and that gives us 729. So we get 729 into the 9th. Can you try number 21? 21 is not that bad. Okay, so we have a power raised to a power. So that means that we're going to multiply. So we're going to multiply 15 times 4/5. So 15 times 4/5. And that gives us 12. Now, one thing to pay attention to is the fact that it's negative. That means that we're going to flip this and we're going to put x to the 12th. Cool. Okay. Let's talk about 23 through 26. Now, on 23, they're asking us to write it in exponential form. So just kind of like a little refresher. If I have the root of something raised to an exponent, and I got this little index in the little cubby hole, then I can write this as an exponential form, as x raised to the exponent divided by the index. Okay, so that's how you write it. Now, there's nothing in this little cubby hole because mathematicians are lazy sometimes and we leave off numbers. So what's actually in here is a 2, and the exponent right here is a 1. So we could write this as 6n raised to the 1/2 power. Notice how I put parentheses around the whole thing, because that 6n is all underneath that square root. On 25, they have this 3 here and a 2 here. So we're going to say 7a, and we're going to raise it to the 2/3. 2 goes on top, and 3 goes on the bottom. Can you try 24 and 26? All right, so on 24, if I'm going to write this as an exponential, I'm going to say 6v. We're going to raise it to the 5 divided by 2. Now, you could simplify this. If it asked you to simplify it, you could. That 5/2. No, I'm going to leave that off. Never mind. It'll probably have this as the answer choice. All right, for this next one, we have 4r. We're going to raise it to the 2/3. Yeah. Any questions over this? Okay, I would like for you to do 27, 28, 29, and 30, and then we're going to talk about them in just 1 second. So you're going to use Desmos. Just a reminder, on 27, in order to do that little 2 down here at the bottom, you're going to hit Shift and then the minus sign, and that'll drop it down. Okay, on your final exam, we can't answer questions like, how do I put this into Desmos? We can't answer those questions. So if you don't know, that's going to be real bad on your part. Okay, so Shift minus gives me that little base. Okay, so really quick, for exponentials and logs, what you can do is you can take this, plug it into Desmos with an x instead of an n. And then you can plug, you can plug this into Desmos, and then you can plug in y equals 243. Wherever they cross over, whatever the x value is, that's your answer. So like, let's say you don't know how to do the little circle of life deal. That's how you can do it without actually like doing math. Does that make sense? Okay, so I would try that on this, as well as you could do the whole circle of life and do it that way. the way you would solve this one is you would start at your base, go to the outside, finish at your exponent. So this would be log of base 3 of 243 equals 1 minus 2n. You would plug this into your calculator, subtract 1, and then divide by -2. Okay. Notice how that would take a pretty long time. Yeah.
Substitute the n we go answer.
You could also do it that way. So she's saying this. Hey, you listening? I'm trying to give you cheat codes. You could also take all these options and plug in for n. You could say 3 raised to the 1 minus 2 times -2. And when you plug that in, you should get 243. What?
That's
Amazing. Use the cheat codes, guys.